explain about my code and how it will be running in the demo. So let's go straight there. So you can see in here, I'm create about the metric to end the size was like 2000. The reason why I'm create really big because I want to see about the time execution, the difference between like about the sequential metric running in the different multiplexing and also like about the running in a parallel programming. So let's go straight to it. So you can see in here, I'm create about a function generate a random metric. I'm just create about in order to make a new metric with about the column and also the rows. And the next thing will like I create another metric to like multiplication of course, and I'm create about the three loops in here, which take a lot of time to execute. And I'm also create about not a function to write a metric to the files. It will, if the file is new, it will show error and access immediately. And the main function is where us like about running the code, right, where it's execute code. And I'm allocate about the memory of the metric on the heap. I create about the true metric A, B, and C, and then I'm create about the starting and the ending point, and the CPU is using in here like speed up the random number generator and then generates random metric A and B, and the starting time and the end time calculated, and then the end time, and then CPU time is used, and then I'm printing about the time execution in here and store it in the store in that result into the output metric multiplication.txt, and then I'm free about the memory because like we already finished coding, so we freeze the memories. So yeah, let me just like clear this one and run the cost of this first. It will take a little bit time. So let me just like come to like about the new thing where like is the parallel matrix and also the OpenMP in here. So you can see like in the parallel matrix, I'm just like this is what like running it about the multi-spreading. It's running like about multi-pressing. I'm a lot like if we are running a 2 press, 4 press, 6 press, or maybe like 8 press, what is going on, what's the time execution between them. And in here everything is doing the same except like I'm adding about one more like about the maximum CPU this like about this calculation can be used. Like the first thing I'm using 2 CPU, next thing 4 CPU, and then another thing with like 8 CPU. Everything is the same except was like I'm using the P thread, I'm using the CPU, which is like it will use more core in order to calculate instead of just using the default core, maybe like 1 or 2 cores to running. So yeah, and everything is still the same except like the first thing I create about a red equal to 2 first, and then a 4, and then 4, and then 6, and then A, something like that. So running it, P crash create, and then join it together again, and ending it, everything is the same. So you can see in here in the sequential metric multiplication calculation, it's showing like about 71.5 seconds, which is taking a lot of time. How about this one, the parametric, which is using about the multi-pressing. So the first thing I'm running it like with 2 press. So the time will be like about less than the sequential because like we are using much more like about CPU to running. So you can see in here is much more than faster than 3 times than the sequential. And yeah, they also got about like maybe like in the A press it's a little bit like higher than the previous one because like maybe like the burst is a lot like it's like about it got conflict in about when it's trained for the data or calculated data, so it will take a little bit time. So I think like in this one like the optimal one will like using force spread enough if we are calculating about the 2000 metric random metric. So let me just like running in about OpenMP. OpenMP also doing the same except was like we are using about the param OMP parametric. So the difference between this one and the multi-threading, like is multi-threading is like using we can use in the different CPUs, but like maybe some of them may be like independent to each other. But like in the OpenMP, everything is running independently, so it will not like when you're running this action, it will not affecting another action. So everything will be running at the same time. So let me just like running this one, and you can see about the difference between the time execution between multi-threading, OpenMP, and also the sequential matrix. So you can see in here the OpenMP matrix multiplication is at 16.1 second, which is faster than about the CPU one. And yeah, that's about it. Thank you.